Okay, today we're going to talk about quadratic functions. We haven't talked a whole lot about it, but a quadratic function takes this U-shaped form, right? That's a quadratic function. If we're looking at formula, like you know how linear functions have a standard form, where the standard form for quadratics is y equals ax squared plus bx plus c. So notice that the highest exponent in a quadratic function is 2. It also takes another form called vertex form, where we have y equals x minus h quantity squared plus k. All right, and it's called vertex form because hk is the vertex. All right, that's the vertex. All right, and when we have standard form, we can easily find our axis of symmetry by taking the negative of b and dividing it by 2 times our a. All right, and that gives us our axis of symmetry. And you may say, well, what's vertex and what's axis of symmetry? Well, if we look at this picture down here, this little dotted line here, it's called the axis of symmetry. And this may look a little blurry, so I'll rewrite it, but it's called axis of symmetry. And axis of symmetry is just the point that divides the parabola into 2 equal parts. And we say parabola, that's just the shape. All right. What divides this U shape into 2 equal parts? That's called the axis of symmetry. All right. And our vertex is, in this case, the lowest point on the graph. All right. This is our vertex. All right. And when we have a vertex, it can be a maximum point or minimum point. And since we have a U shape, it reaches a minimum and then goes back up. So this actually has a minimum point, but that's the vertex. Okay, a couple of other things that we already know because we are familiar with x-intercept and y-intercept. When we look and see where the graph crosses this y-axis, that's our y-intercept, like we studied in linear functions, exponential functions, right? And then if we look here, we see 2 points where the graph crosses the x-axis. All right, these are the x-intercepts. But we have other names by which we call the x-intercepts: roots, solutions, zeros. All of these names we call the x-intercepts. Okay? That might have been a whole lot of information right there, but we're going to look at some examples. All right, that's the point where we're going to next, is some examples. Here we go. All right, so when we look right here, it says identify key features of quadratic functions. Notice how here we have a U shape, but it's pointing downward. And so we're down here, we come, reach a point, and come back down. So that's called our vertex right here, which is a maximum, and then we come back down. Okay? So let's go ahead and make that note. This vertex is a maximum. Okay? So what about our x-intercepts? Well, our x-intercepts are the points that cross this x-axis right here, right? So try to identify those. All right, and hopefully what you figured out is that there's a point right here and there's a point right here. This point here is in between 0 and -1. So let's say it's -0.5 for our x-intercept. And then this other point here is the point in between 2 and 3. So let's say that point is 2.5. And our y-intercept is right here, the point where the graph crosses the y-axis. So that's 2. Our vertex, we've already gone over and identified it, but let's identify the point. Our x here is 1. Our y is 4, so the point is 1, 4 for our vertex. And then it says the point of extremium, circle 1. Well, we've already said it's a maximum point. Extremium just means how high or how low it goes. In this situation, it reaches a max. And the bottom of it, there's no end. It continues to negative infinity because of the arrows. So we circle maximum. And the axis of symmetry, remember that's the line that divides the parabola into two congruent parts. So it goes directly through the axis of symmetry. I'm sorry, directly through the vertex. It's called the axis of symmetry. So what is this line that goes through this vertex? Remember, vertical lines have an equation of x equals. Since it goes through x equals 1, the equation of this line is x equals 1. And that's what we write here, x equals 1. All right. So then the next three parts says, what are the roots, solutions, and zeros? If you remember from our notes, roots, solutions, and zeros all just mean the x-intercepts. These all just mean the x-intercepts. Well, we already defined it. We said, right, negative 0.5, and we said 2.5. Now I'm just writing it in point form. And then you write the same thing here. Now you try number 2, looking at number 1 to guide you. We're going to go to number 4. If we look at number 4, we have this U shape, right? Have this U shape, where first we're going to identify our x-intercepts. So the point where the graph crosses this x-axis. Here and here. The x-intercept is negative 2, 0 and 0, 0, also known as just negative 2 and 0. Well, what's our y-intercept? The graph crosses the y-axis right here as well. And that's where y is 0. So that's also the point 0, 0. And our vertex or extreme point is right down here. This is our vertex. Our x is negative 1. Our y is negative 2. So this is negative 1, negative 2. And the point of extremium, it's a minimum where our y is negative 2. Don't forget, the axis of symmetry goes directly, it's a vertical line that goes directly through the vertex. And notice it goes through x equals negative 1. So that's the equation, x equals negative 1. Roots, solutions, and zeros is the same as the x-intercept. So we just take what we wrote for the x-intercept and write it in these spaces. So that's negative 2, right? And 0, negative 2, 0, negative 2, 0. All right, we can write them as a point or not, okay? I'm going to erase these little parts so there's no confusion. All right, and when we look at number 5, what we should notice is that this graph is an upward parabola, but does it ever cross the x-axis? The answer is no. So therefore we say that there are no x-intercepts, which means that the roots and solutions, there are no solutions. right? No roots, no solutions, no zeros. Now you try the other ones. Y-intercept, vertex, point of extremium, and axis of symmetry. Then try number 6 and we'll go over it together.